Good morning, everybody. This is Brent Jeffries with Bierer Meters, Vice President of Field Operations and Safety Trainer and Speaker. And you guys are here today. We're putting on what we call a ECOS Linemen Tech Tool National Webinar. This will be 003. And we're going to talk to you all about some tech training, some tool training, a lot of safety as well. And we're going to try to do these monthly. The next one will be Bulwark FR clothing, shirts, pants. Derek saying he's coming in and he's going to be doing the training October the 4th. So he's a lot of folks know him. He does a lot. He brings in a lot of safety on his speeches and shares. So tune in for that October the 4th. That'll be good. To register to ECOS, just all you have to do is text capital BIERER to 22828 and you'll be registered. Put in your company email, you'll be registered. So this is what we're doing. We're starting this Bierer Meters. We started this about 6 months ago. These national webinars. It'll be Jim Duncan, as you can see. He's going to be coming in September the 14th, and he's going to be talking about interpersonal communication. So it's important. We got some good videos. We have a videographer, Jeremy, and his crew comes and videos these, and you can have these as registered members of ECOS. You can have these videos and use these for your line crews forever. Edit them, cut them up, do what you want with them. All right, bits and pieces. We have 6 really good videos that you can obtain right now that are excellent. We have Danny Rains, Lito Wilkins, we had Caleb Thompson, Brady Hansen. We had Billy Martin come in. Rod Courtney came in last month. Great videos, awesome. Every one of these folks, they're bringing a component, a separate component from their own heart. And what they're doing is it's all being combined to one big electric culture of safety. We'll talk about that more later after we do some of this training. So we have a special guest today, Miss Abbi Davis, and we'll give her some time here. Okay.
Hi everybody, my name is Abbi Davis. I am from Harkers Island, North Carolina. It's a small commercial fishing community on the coast in the middle of nowhere. You've probably never heard of it. I went to college in North Carolina and graduated with a degree and realized that it wasn't for me. It wasn't what I wanted to do for the rest of my life. So came home, got a job at home, made a lot of friends at that job because it was, working at a restaurant. And one of my friends said, you should look into line work. So I did and went to line school, worked with a contractor for a while, and that eventually led me to where I'm at now, an apprentice lineman at Fairfield Electric Cooperative here in Blythewood, South Carolina, which is where I live now. So that's kind of my journey, and I love helping people, hard work, and being outside, and being in this field kind of encompasses all that, and it lets me live my passion, and I get to do that every single day.
All right, thank you, Abbi. So Abby's going to be helping me some during this training, and this is going to be open forum. We travel all around the United States and do this for folks, line crews, speak at safety conferences as well, and this is going to be open forum. If you have a question, please go ahead and text it out, type it out, and Jeremy will let me know as we go through what these questions are, and we can kind of answer them and talk about them. All right? So we're going to get started here. Everybody ready? You guys can hear me well? Thumbs up. Everybody's good? Good? Okay. All right. Awesome. Good. All right. That's good, Abbi. So what we're going to do, thank you. What we're going to do is we're going to talk about, so the safety and tool training that we're going to talk about today is going to be from a non-biased perspective. It's going to be, we're going to talk about how these tools operate regardless of manufacturer. Bierer Meters, as you all know, we build some really nice products, voltage indicators, phasing tools, corded, wireless. We'll talk about all those applications, all those work methods for those particular tools, but it's irregardless of whose product you use. The safety is going to be exactly the same, all right? So what we want to talk about first is how these tools operate. And what they do is we've got a battery test on every tool, whether it's a push button or whether it's a switch plate. Ours happens to be a switch plate. The battery test, simply on a Horn and light, you're going to see and hear, all right? And what that does is it simply tests just the battery. It does not test the tool functionality on a live known voltage source. We'll talk a lot about that today, testing the tool on a live known voltage source. It simply tests the 9-volt battery, which is underneath this quick change here. So you just undo the quick change, tap out that 9-volt battery, put a new one in, make sure that your 9-volt battery is new, it's fresh, and then you're going to test it again. If you do not hear and see that horn, and you have a new good battery in it, then what you want to do is you want to go ahead and tag the tool and send it in to us for repair. All right? And we repair all of our tools 10 years, 20 years down the road, whatever. We can recalibrate your tools as well. As far as recalibration, that's up to the user. It's really dependent on if you test your tool on a live known voltage source and you're getting accurate readings, accurate results, then obviously your tools are calibrated. So we leave that up to the customer. We suggest once a year, but again, sometimes we get the tools in 15 years later and they need repaired and calibrated, okay? So that's gonna be your choice. So on an analog tool, anybody's analog tool, you're gonna just test the battery and you wanna see that needle deflect. And you wanna see that needle go all the way, deflect all the way, nice, hard, fast. If it's partial or does not deflect, change out the battery. If the battery is good and you still do not see the deflection or it's just partial, turn the tool in, it needs repaired, okay? We build all these tools from scratch right behind us over here, actually behind these guys, right over here in South Carolina, and so we build them from scratch so we can make the repairs, all right? A digital simply is going to give you the digital battery reading itself. So you simply take the switch plate, go to battery test, hold it in 8.6 volts. So if you see 7 volts or lower, change out the battery. 7.2, I would go ahead and change out the battery, all right? Just make sure you got a good battery in it and the tool's going to work well for you. Okay, so that's the battery test. Care. What you want to do when you're using these tools is you want to understand that every one of these products, the voltage indicator phasing tools, they have a line limit right here. ASTM wanted us to put a line limit. And what that does is it lets the user know that you do not want to bypass that line limit with a potential ground or another hot phase right here, okay? The reason being is because right here is where we put the resistors. The resistors are in here that's going to protect the tool from that primary source. It's going to protect the tool from it, and it's going to be looking at more of a lower voltage, you know, secondary type voltages, okay? So, and we'll show you all that later. So the resistors are here. So you don't want to bypass those because that's your protection. So if you're using the tool and you come with a ground plane near the tool or another hot phase, you could have a flashover. That's the biggest call we get from the industry is a flashover because the linemen, typically they're going to receive these tools, phasing tools, voltage indicators, corded, wireless, and they're going to be handed the tools. They put them in their line truck, and the next thing you know, they're not received any training on how these tools work whatsoever. They're just handed the tools and tell them go to work. But the linemen don't really understand how these tools function. So we're going to talk about that. What you want to do is you want to make sure the probe is clean. Hot stick wipes are great. Use hot stick wipes on your probe. No calibration stickers. That'll keep from tracking, outside tracking. Inside, we put epoxy, so it helps keep environmental elements outside the inside of the probe, all right? So you don't have internal tracking. That's really important. When you're using these tools, you're always going to remember that the tool, when you make contact with the conductor, the tools must be energized in order to give you a voltage indication. When you're phasing, wireless, corded, whatever, the tools must be energized. They are not isolated. They are not insulated completely. All right, somewhat, but not completely, so they are energized. It's important to understand that. So take care of them. All right, so when you're using these tools, you want to remember that that line limit you're going to create in your imagination, in your mind, you're going to create a sphere around that tool, and that sphere is going to circle that tool, the meter head, the back, the front, all the way around that tool, and you don't want to enter into that sphere, that air dielectric, your best friend, with a potential ground or a hot phase. I was doing training in Texas back in February, And on my way to train in Texas, I was in Louisiana, and I get a call from the safety guy, and the safety guy says, hey, we just had an arc flash. The same people that I was going to bring our lineman safety and tool training to. They said, hey, we had an arc flash, and I didn't quite get there quick enough, obviously. And they showed me the picture, and sure enough, this is the picture we see all the time when there's an arc flash, all the time. Different components, different states, different scenarios, different line workers, all right? But we see the same picture, and that picture is simply there's a ground potential or another hot phase next to the tool when the arc flash took place, all right? So always make sure you protect your best friend, that air dielectric, around your tools, regardless of manufacturer, is corded or wireless, all right? So how they work, this is how everybody's tools work. They make contact with the conductor. The conductor we're going to call X, whether the X is going to be energized or that conductor is de-energized, that's your X, all right? So we're going to make this equation on how these tools function. It's real easy to remember this equation. Plus Y. X, the conductor, plus Y. Y is tool functionality, how these tools function. And how they function is very simple to remember. When they make contact, the tool looks at that current, couples with the capacitant, and looks at that current in relation to the ground plane. And remember how these tools are designed. They are designed that the tools are built so they look at the ground plane as the ground plane, not you as the ground plane. So remember this, so important. When we calibrate these tools, we do not calibrate these tools in our calibration room, right over yonder, with our hands on the stick, short stick, and our tool glove and these tools when we calibrate them. We simply place them in that hot bushing, and we're away from the tool, and that's how the tools are going to be accurate. Not only that, but safe. So if the tool has a cord on it, it's going to look at that current in relation to the ground plane through the cord. And you have the secondary probe, similar to this over here. You have the secondary probe on a ground plane, which is right there in that cabinet on a ground plane. All right? So the tools function exactly the same, whether the tool is looking at that potential through the air to the ground plane or through the cord to the ground plane. The Y, the tool functionality, is the same. Everybody get that? Okay? Equals. X plus Y equals. The equal is very simple. It's going to be first equals safety. Most guys, when they're out in the field, they're going to be looking at the indication, the information. But we're not going to do it like that. We're going to go equals safety and accurate information gathering. All right? So X plus Y equals safety and accurate information gathering. This is so important that you all, when you're using these tools, you're looking at phases. You're out of phase, in phase, before you make a tie, whatever you're going to do. You're going to balance some load, or whatever you're going to do. You're using your tools to verify something, all right? What you want to do is you're always going to make sure that you are away from that tool, because you are a ground plane. Your bodies that you borrow for a short time, very short time, is from dirt and water. So you're a walking ground plane. You're living, breathing, walking ground plane on wheels. That's what these are, wheels, okay? So make sure that the tool, when you're using it, the tool is looking at the ground plane and not looking at the ground plane, all right? So what we're going to do is we're going to go ahead and we're going to go to our VD1000P. The P is for proximity. So it does have a proximity setting on it, which gives it a little more function. You can use it non-contact initially, all right? Which is kind of cool sometimes, just to verify if something in your area that you're working is energized or not. So we got our PP on. We're going to use our tools. And you're going to be using your hot sticks. Make sure that when you're using a device, phasing tool, voltage indicator, you're always going to use the proper accessory on that cone tip. You got a straight probe, bushing adapter, a hook probe, maybe an elbow adapter going into the elbow. Always use the proper accessory. If you do not have the proper accessory on, and you just simply take a shortcut, and that's what it's called, a shortcut. It's not proper work method. And you do not use the proper accessory, and you simply use the end of the device, which you can do, but it's a shortcut, it's not safe. Remember, it does not equal safety. And the reason why is because you always want to make sure you do not bypass that line limit, the resistors, your protection. So if you have the proper accessory on, the opportunity to bypass those resistors is much less. So it's a lot safer. See how that works? So always use the proper accessory. Okay? Also, when you're using these tools, you do not want to do what we call short stick. All right? If you're a lineman, you don't want to be called short stick. All right? So you're not going to be choking up on your stick. You're going to have your device on your hot sticks that your job allocates in your truck. You're going to be using those hot sticks. You're not going to be tool gloving either. This has never equaled X plus Y. This right here, short stick or tool gloving, this is X plus Y equals no safety. It's not even a work method. This is not a work method. Should never be done. And this is not a work method, short sticking, and should never be done. Never has equaled safety. I've talked to so many linemen and says, hey man, I've been tool gloving with my voltage indicator for 20 years. I've never had an issue. Yeah, well, it's never equaled safety. So that's one issue that's wrong, unsafe, right here. So you mix this unsafe practice with another unsafe practice or an incident that took place at the same time you were using the tool unsafely, all right? You mix the two together and folks are getting hurt. All right, I'll tell you about mixing two together. Check this out. I was in California doing some training for utility. And one of the linemen came up to me after the training. And this happens quite often. They don't want to tell anybody. They don't want to speak up. They don't want to communicate. They're embarrassed. They're ashamed. And that's the thing. They're afraid. All right? They're afraid of retribution. They're afraid of embarrassment. And you all, your line workers out there, all your guys, your CEOs, your superintendents, your groundmen, your journeyman linemen, your lead linemen, your safety guys, all you folks out there need to speak up and communicate and talk together. And we're going to talk about that at the end, right here. We're going to talk about that. You need to communicate together. Because if somebody makes a mistake and an incident takes place, and let's say it was a near miss and they don't want to tell anybody about it, how do we learn from it? How do we improve? How do we become better with ourselves and each other? How? It just doesn't happen. It's impossible. So we got to be warriors. All right? We're going to talk about that warrior mentality. And we've got to speak up and talk and not be afraid. All right? Hey, we're human. Every one of us makes a mistake. Every one of us, I don't know about you guys, but I make multiple mistakes every single day. That's why on my computer, I got whiteout on my computer. If I type the wrong thing, say the wrong thing, you know, I go over and I review something before I hit send. All right? Maybe I made a mistake and said the wrong thing. So I get whiteout and I fix it. All right? And too many folks out there are trying to fix the worker. And we need to fix the work and be a team, what we call a line team. All right? So no short sticking, no tool gloving. And what he told me, he came up to me and said, hey man, hey Brent, appreciate the training. One time, and it's only one time that these incidents takes place, and someone learns a lesson. Unfortunately, someone may lose a body part. Somebody may lose their life. A wife could lose her husband, or a husband could lose his wife. Could happen. It just takes one time. We'll talk about that as well. He went to that capacitive test point on the elbows in California. One time, barehanded, after about 20 years of tool gloving. One time he went to the capacitive test point barehanded. And he got hit, as you all know, because the tools are energized, he got hit with about 200 volts. All right? So, scared him. He only did it once. No one else knows about it except me. But I'm sharing it. We need to share. Now, you all know about it as well. So let's talk about it. Okay? So we have here a 3-phase overhead line. All right? That's what we're going to call this right here. You're going to use your imaginations, your creative side, your right side of your brain. All right? We're going to use it. And what I'm going to do is this overhead line is real close to the ground plane. All right? Maybe you had a little storm or something, that pole snapped, and that line is close to the ground plane. So what I'm going to do is we're going to take our tool and we're going to put it in URD. All right? And if you go to Texas, again, I hate to pick on Texas, but they're good customers of ours and they're fun to pick on, okay? They say everything's bigger in Texas. Don't believe them, okay? Anyways, we're going to put this tool in URD. And the reason why we're going to do that is because we're close to the ground plane. We're the only manufacturer that builds a tool that discriminates between whether you're close to the ground plane or far from the ground plane. That's pretty cool. That's what we do. So we're going to be URD or OH, overhead. So let's say that pole ain't broke and that 3-phase overhead line, those conductors are high. 35, 45 feet off the ground, we're going to go OH. Let's say we're doing some transmission work where Abby came from. Those contractors in North Carolina do transmission work. So we're going to go to OHT, overhead transmission, because we're far from the ground plane. All right, makes sense? Because you know how these tools function. So why not put it in a switch at a position that's going to be more accurate? But here in this case, what we're going to do is we're going to put it in P for proximity, just to come up to our conductors, point source, we got a long source, whatever you have, just to verify if something's energized. Verify our tool's working, verify our head's in the game. So here we go. And you all see those numbers coming up on this overhead line. So we know at least one of those phases is energized. Let's say you have capacitive test points and you have dust covers on your capacitive test points. You can simply go to the base of your elbow and it'll pick up that semicon material in the base of your elbow just to verify if it's energized or not. Or maybe you don't have capacitive test points. You have secondaries. You can approach secondaries as well. Okay? You guys get that? All right. But typically, what you're going to do is that's just a first case scenario. Maybe you're doing some storm work. Maybe you have some lines on the ground. It's dark outside. They're in the bushes. You're not sure where they're at. So you'll use it in the P setting initially. All right. But typically, we're going to go ahead and we're going to go to URD. And you always want to make direct contact with your device. If you use any tools that are non-contact, and a lot of folks do still today, the good news is a lot of those folks are chunking them. All right, throwing them in the trash. And that's good. They're non-contact tools are a little safer than keys and wrenches. A little bit, give you a little more information. But if you're going to be talking about some safety and what Brady Hansen calls your scriptures, OSHA 1910, we're going to go to 0.269. 0.269, you go to lowercase n, talks about your grounds, talks about your TPGs, your temporary protective grounds, and you go down to number 5, and it says that prior to placing and installing your TPGs, you're going to verify that your conductor, you're going to verify it's de-energized of your nominal voltage. All right? That's what it says. But how we like to train when we travel around is we want to train that your tool is going to be accurate enough, direct contact, to verify an absence of backfeed, induction, as well as an absence of your nominal voltage, your system voltage. Okay? So that's what we're going to do. That's how we're going to train it. And a non-contact tool doesn't give you that information. If you're on an underbuild, you're not going to get that proper information. You can get false positives with non-contact tools. You can get false negatives with non-contact tools. So what I do with non-contact tools is we got a dumpster over here that gets picked up once a week. And if you have a non-contact tool, just put it in the dumpster. Maybe it's, you know, got some recycled parts on it, that's fine. But chunk it, all right? That's the main thing. If you've got some safety guys that are unsure, you got some operations managers that are unsure, or some tool work methods guys that are unsure, have them call me. You guys can call me, contact me, and we'll have a discussion. Usually takes about 5-10 minutes at the most. And then they make a good decision. And they fill up their dumpster. And their linemen are a lot safer, and they're verifying 3 types of voltages, no longer just the one. I think that notion needs to be changed. All right? That's just my personal opinion. All right. Everybody good? Any questions yet, Jeremy? No questions? Okay. All right, you guys can ask questions. Remember what we talk about. Speak up. That means ask questions. All right. So what we're going to do is we're going to take our tool, and how we're going to train this is we're going to train this 5 steps. Skylar, you about know these 5 steps now, huh? You might know these 5 steps. We're going to train these 5 steps. Abby, you're going to know these 5 steps. And those 5 steps are real simple, easy to learn. And this is how we train everywhere around the country. We take our show or demo trailer, we're asked to come to a safety rodeo or safety days, and we use our trailer as one of the stations. What we simply do is we just say, hey, we'll do it our way, and if it's okay, then we'll come out, okay? It doesn't cost anything for us to come out and do some training or speaking. We do it all for free. That's what Bierer does. Free safety, man. It's an awesome thing we got going on here. And you guys, I'm glad you guys are here, because this is what it's about, sharing right here, okay? All right, so what we're gonna do is we're gonna do test, open, test, test the tester, ground. You see that? 5 steps, all right? That's how we're going to do this. So first, the reason why we're going to test first is we want to make sure the tool's working. Remember, we talked about this. We want to make sure the tool's working on a live known voltage source. Remember that? We talked about that. Not the battery test. The battery test, we passed. It's good. But now we want to test the tool on a live known voltage source. That's the one reason. Make sure the tool's calibrated. We got an idea of what our system voltage is. That's fine. Maybe we're phasing, we're out of phase, and the tool, wow, look at that voltage. We're definitely out of phase, and it's still calibrated. We're happy, all right? But we want to test the tool on a live known voltage source prior to opening the switch. Every job site, every equipment, if at all possible, every day, all day long, every day, our entire life, all right? And the biggest reason why that we want to test first, even bigger than testing your tool on a live known voltage source, the biggest reason why is because we want to establish the fact that our mind's in the game. We want to establish the fact that we are in it to win it. That I am personally accountable to you, Simon. Okay? Or to you, Abby. I'm personally accountable at this job site. I had a good night's sleep. I had a good dinner last night. Had a glass of wine, but I didn't stay up all night. I didn't get drunk with the other boys. All right? I got some good rest. And the reason why I did that the day before work, the reason why is because I am personally accountable to everybody on my crew. Okay? Mutually accountable. Reason why we test first, live known voltage source, is we're going to verify that we, as a crew, are mutually accountable one to another. See how that works? All right, Abby is mutually accountable to me. Boom. I'm mutually accountable to her. Boom. All right, so we're going to work together. That's part of that equation too. Here, communicate. We're going to do our 2-minute walk around. We're going to do our job briefing. We're going to do our tailboard, whatever you guys want to call it. We know our risks. We know our hazards. We've established all that, all written out. Anybody have any concerns? Abby, she's an apprentice. She's coming up in this business. I tell you what, though, the female side, they are really big on details. And if Abby sees something at this job site, I may not see it, and I want to listen to her. I might not like her. Maybe she's a smart A, huh? She gives me a hard time on the job site. I've been doing this longer than her, but she's mean to me. I may not like her, but I'm going to listen. I'm going to listen to her. All right? We all listen to each other equally. We're all equally the same when it comes to our safety. Right here. Right here. Equally the same. Okay? So we're going to make sure that's on the job briefing, that list. We're going to make sure that that bottom of that job brief, we're going to sign off of it. And when we sign off of it, we don't sign off of it. That job brief becomes part of us right here, part of us right here. We don't sign off of it. We put our name on it and we agree to those terms. It's a contract. We agree to those terms throughout this job, throughout this work that we're doing, accomplishing this day. We agree to those terms, mutually accountable. I'm going to keep my eye on her. Okay? I took care of myself last night. If I was out late last night, I didn't get enough sleep, and I was drinking too much, guess what? I should not be at the job that day. I need to dismiss myself. And after a while, guess what? I probably won't be a lineman. Too much drinking. And what happens is if you are not mutually accountable to your folks on your crew that day before, that night before, you shouldn't be on the job. Because what happens is when there's no mutual accountability, what happens is folks get hurt. Folks get hurt. And guess what? They do a risk or a incident analysis, right? They go over that. And does on that analysis, does it show that those folks were all accountable or anybody not accountable? Does it? They don't ask that question. But that's where a lot of these incidences, that's the reason why they're happening, is because somebody on that crew, somebody, just takes one person, was not mutual accountable to the rest of the folks on the crew. Just one person. One incident, one day. This is serious business, folks. This is serious business. You are working in, to me, it is the best industry, the best form of work. That's what Abby said. She got out of college and she did the best work that she knew was out there, was line work. All right? And it is. It really is. Just don't tell everybody, even though you guys need help on your crews. Keep it a little bit quiet. You guys get paid good, all right? But like Abby's saying, that's not the main thing. I was talking to her earlier. That's not her main thing. She just loves the work. So if you love the work, you need to be disciplined and responsible. So we're going to test first. All right? Oh. Don't want to go there. Here we go. All right. You all see that? All right. So we're on 13.8 right here. That middle hot bushing is 13.8. We'll call that our B phase or whatever phase you want to call it. That overhead line, right? Remember that? And it's about 13.8. But see the head, the meter head, remember how they work? The meter head's pretty close to the ground plane. Pretty close. So we would expect the meter head is close to the ground plane and maybe another source nearby. So we would expect that the reading is going to be slightly skewed to the upside because we know how these tools function. And sure enough, if you go to, that's what the guys tell me in Texas, they say, sure enough, the reading is a little high and that's to be expected because we know how these tools work. All right, Miss Abbi, want to go ahead and close that switch or open that switch. So Abby's going to establish a visible air gap. She's going to have a lockout, tag out, visible air gap, and she's going to open that switch and she's going to put a marker, a flag. Maybe she's a contractor and the particular contractor has a particular flag denoting the contractor or whoever opened it up, that it's open for a reason. All right? So she's got it. She established a confirmed open air gap, air dielectric. Remember your best friend, all right? So now we go to that conductor, long source, point source, whatever that conductor is called, don't matter, and we make that contact. So we have test, open, test. The tool that we use, that you all are going to use from now on, is accurate enough that you're going to verify with your tool that you have an absence of nominal voltage, because OSHA says so. But because you guys are smarter and you guys are being trained with more safety than ever before, we're stepping it up a notch, guys. Remember, this is called electric culture of safety. This is about everybody right here, everybody. Owner of the company, CEO, down to the beginning apprentice. Everybody's got the culture of safety, and they're sharing it, they're talking about it, they're it. We're gonna live it, we're gonna breathe it. It's part of all of us, all right? So the tool says we don't have any induction or backfeed. All three voltages absent, all right? So what we're gonna do next, the fourth step, is we simply test the tester. We have a 3 kV power supply right here, which is great in your kit. And we also have a handheld power supply, all right? We just sold a couple hundred of these in our kits this week. Mr. Duke, good customer of ours. And we got a handheld power supply, and we're gonna test the tester. You all see that? Test the tester, all right? So the tester has been verified that it was working properly, and we know for a fact that there's an absence of all three voltages on that conductor. Point source, long source, overhead, underground, whatever, all right? So you test the tester. Now you can take your TPGs and you can install your temporary protective grounds. Set up your EPZ. You're gonna set up some bracketing, whatever you're gonna do to protect the equipment and to protect yourself. Capiche? Good? All right. All right, good, Abby. You can turn it back on. All right, so that's how we're gonna do those 5 steps. Open, I'm sorry, test, open, test the tester, ground. All right, there we go. Abby threw in the switch. Now what we're gonna do is, you know that call we get the most of, and we talked about that, arc flash. You can see in this cabinet, we've got couple elbows here that are close to the cabinet. Maybe you inspect your cabinet and you happen to have some bleed wires that would be close to your device prior to use. So what you want to do to prevent arc flash is you're simply going to install a 0 ohm extension. Okay? You got the 0 ohm extension, and what that does is it takes this scenario where that component, that danger, you want to mitigate it. So you're going to take this situation from happening and you're going to install the 0 ohm extension, and now you create that air dielectric. You're going to protect that meter, you're going to protect you. Okay? All right, so let's use it and see what numbers we get. So we got our 0 ohm extension on. A lot of folks are getting their kits. After our training, they realize, hey, that's pretty smart, that's real safe. And they're right. All right? You see those numbers? This is 13.8. Those numbers without the 0 ohm extension, remember, we're about 16,000 volts. But now with the 0 ohm extension, we expect to see a more accurate reading because we know how the tools work. Because now the tool, the functionality of the tool with the 0 ohm extension is now further from 2 things that affect the functionality of the tool. Remember, we talked about it. What 2 things is that device, anybody's device, what 2 things is that device further from now? You guys tell me. Okay, type it out. Type it out. You guys got it? It's very simple. Anybody typing, Jeremy? Man, come on, guys. All right. So 2 things that that device is further from. Remember, this is with anybody's device. It's further from the source. All right? And the tool is further from the ground plane with the 0 ohm extension. So now what we do is we almost have true RMS voltage with this wireless. Digital. That's almost true RMS voltage because we're using it safe and we're using it properly. So X plus Y here in this case equals better safety and better information gathering, more accurate information gathering with the 0 ohm extension. All right? See how that works, guys? Gals? Okay? So there we go. So I'm going to, okay, so Abby, you ready? All right? So come on around. And you can use that PD25 there. All right, so we're going to show you guys some things. Abby's going to show you guys some things. And what we're going to do is we're going to use the tool safely, proper work methods, and then we're going to use the tool unsafe. And what Abby's going to do is she's going to read the voltage on my body, on my boot, on my back, and on my inside glove. We're going to read it. She's going to use a PD25, which is true RMS voltage, plus or minus 1%. And it starts working at 1 volt. We call it a multimeter. It's a very safe tool. Nothing like it in the industry. Fact. You can use it for about 10 different purposes. All right, AC, DC voltages. It's got the cord is shielded at 35,000 volts. We're the only manufacturer that builds, customizes a cord that's shielded. No one else does that in the industry. We're a family company, so we can do whatever we want. How's that? Okay, so it keeps you guys safer. Takes a little more resource, but you guys are safer. So we do it. All right. This is one of Walter Bier's. He's my stepdad. He's the owner of the company. This is one of his 17 patents, is this tool right here. So it's pretty cool. All right, so Abby, go ahead and put it in 2 kV. So she's going to be looking at secondary voltage on my body, okay? All right, you want to get over here, Skylar? Okay, Abby, go ahead. I'm going to use it safely. And go ahead and read that voltage. You see my air dielectric, guys, on that stick? I'm using your hot stick. What you got, Abby?
22.
All right, you guys see that? 22 volts. I'm working safe. You remember our air dielectric is my best friend. Right here, air dielectric. If I'm short sticking, what happens is I literally kick my air dielectric to the curbside. All right, so now I got rid of my air dielectric, my best friend, and now what do we get?
48.
See, voltage almost double. Actually, more than double. Check out the back. Abby.
189.
189 volts. See that, guys? This is reality, short sticking. So now my body is coupling with the capacitance, and the tool is looking at me as a potential ground plane. That capacitance, when you're working hot, all day long, you are coupling as a potential ground plane. All day long, you are coupling with that capacitance, whether you like it, whether you care about it, or not. That's how it is. Walk underneath the transmission line. Maybe on a foggy day, you might feel a little snap, crackle, and pop through your body because you're coupling with that capacitance. It's going home. It does. All right, that corona. Got some loose electrons, huh? Floating around the air, and they're coming on you because you're a great ground. That's because that's where you're from, is the ground. All right? So short sticking has never been safe. Okay? Go ahead, Abby. Grab that inside the glove.
71.
71 volts. Do it from out here, Abby. What you get?
29.
29. More than doubled. But see, let's say I'm a lineman. I never had the lineman safety and tool training. Never saw a video. No one ever taught me how these tools function. I don't know. All right, I've been doing this for 25 years, let's just say. Because it happens, I've heard stories. And I'm going to be a tool glover. Okay? And that's a horrible nickname to have for your lineman. All right, so I'm going to be tool glover. Go ahead, Abby. Boot.
46.
46 volts. Okay, try the back.
462.
Woo, 462. Okay, inside glove.
112.
112. Y'all see that? You see how unsafe it is to be a tool glover? There's no safety in that. I know a lot of folks, they've been doing it all their life, but you all need to understand, every one of you guys are super important. Every one of you all have great importance, and you're going to affect and influence many, many folks in your career, in your lifetime. And it starts like every day. That's when it started. It started yesterday. All right, and that influence and that effectiveness, most of the training that you do for others are going to be through your example. What you did out in the field, not anything you might have said or didn't say. It's going to be through your example. And let's say, and this happens, let's say through your example, your bad habits. It's not a work method, it's a bad habit. That line worker leaves, Abby leaves. She's got a job offer because they know she looks at detail. Abby's safe and people want her. All right? They want her on their crew. So she's valuable to everybody on that crew, and they want her, and she leaves. But let's say somebody, when she left, was teaching bad work habits, maybe short sticking, tool gloving, and Abby picked that up and she took it to this other utility with her. All right? Somebody on that utility sees what she's doing. She starts teaching through her work methods. Somebody leaves that utility, takes it to another utility. Someone loses fingers, hand, arms, or death. All right? You see how this works? We all influence and affect each other. You know, you heard the saying, this is a small world. Man, I tell you what, it's a real small world. And these stories, I'm doing lineman safety and tool training for 5 years now around the country. Because I do the safety for these folks, and I'm in tune and I'm in touch and communicate with a lot of safety people, a lot of ECOS, a lot of CUSP people now on ECOS, certified utility safety professionals. And I hear these incidences. They're doing incident investigations, and they let me know, hey, this is what I'm looking at. No names. I don't need to hear no names. What are you thinking about this? Or what do you say about this? You know, they didn't check for voltage. They didn't check for a lack of voltage. Boof. You know, 2 guys last hurricane season, 2 young apprentices. Storm work. Think about it. Storm work. They get smoked working storm damage from a past hurricane last year. Smoked, both of them. Do you think they learned safety? Do you think they had their device verifying, energized, hot or not? Do you think so? All right. So, and you guys see this meter head. Let's see that meter head. Let's say I'm in that cabinet on that tight bushing next to the wall. You see that spin on me? If I didn't have a 0-ohm extension, that meter head is making contact with that cabinet right there. Arc flash. Think about it. All right? It happens all the time. Okay. So we were doing training in Tennessee, and a couple linemen, we were doing test, open, test to test or ground about 4 years ago. 2 linemen said that they had an arc flash. And what happened was one of the linemen was using their gloves. The other guy was using their gloves and a stick. And he was working elbows hot on that cabinet. He had his air dielectric, and he was working safe. The other guy noticed the cabinet was a little loose from its foundation. So always remember, you got to have a good foundation in your life. That's important, okay? And the guy that was not on the stick, he had his gloves. And what he did is he trusted a good friend, not his best friend, air dielectric. He trusted a good friend, gloves. And he put his gloved hand on that cabinet and he got arc flashed. Went straight to ground. Bypassed his gloves, coupled just enough to bypass his PPE and get him in the arm. Boom. Spent some time in the hospital. No lost digits, no lost nothing. But got burned up a little bit. All right? Did not have to happen. That incident was completely preventable. He kicked his best friend to the curbside. Try that. Go home. All right? And get in a fight with your best friend, your wife, your husband, and see how that goes for you. All right? Always take care of your best friend. Always. Okay? So they said the reason why it happened is because in those cables in that cabinet there was rat piss. And that's what happened. So, Abby, can you hold this right here? You can set that. There you go. They said there was rat piss in the cables and they got away with it. That was their story and they were sticking to it. So what happened is, you guys see those numbers? I got gloves on. Watch these numbers, okay? What's happening? They're going up. They're going up. They're going up, aren't they? All right? You guys know why they're going up. You all know for a fact. This is not a theory. This is reality. This is what you guys work in all day long when you're working hot. You're ground, and if you work unsafe or safe, that capacitance is coupling with your body either way, but if you give that potential a path home, it's going to complete the journey, complete the circuit through you. It will, I guarantee. It's not going to ask you for permission. It's not going to knock on the door. It just does it. In less than a split second, it just does it, okay? So what you want to do is, when you're working the meter, is you want to stay away from that meter head. No short sticking, no tool gloving. Get back. We recommend 31 inches minimum from the device because of arc flash measurement, but I like to train 36, and that's widely accepted as 36 inches back on your hot stick. I heard folks are getting electrical tape, hand guards, whatever you want to do, that's fine, don't matter to me, but just get back. Establish training and establish a visible reference. Visible reference, not just training, but a visible reference, okay? It's real simple to do, all right? Awesome, thanks Abby. Any questions thus far out there? Anybody have any questions? Good? Got a good bunch of people, huh? Good bunch of folks out there. Okay, so what we're gonna do real quick is we're gonna go over phasing. All right, Abby, let's go ahead and let's go ahead and do some phasing here. If you want, go ahead and take that PD25. We're gonna go talk about phasing safety. Now remember, that cord is to always be considered part of your tool. So you want to stay away from that cord. Whatever distance you're to stay away from your device, the cord is part of your device. So stay away from the cord about 36 inches, 31 inches, whatever. All right, Abby, go ahead. Go ahead and come over on this side and take a reading off that middle capacitive test point, that white phase. 2 kV power, okay. All right, so we're gonna go phase to ground. What you got, Abby?
127.
127, okay. And what we're gonna do is, what we did is we went phase to ground. So when you're phasing, you're always gonna verify that you have power, obviously. You're also, when you go phase to ground, you're gonna verify the tool is functioning properly on a live known voltage source. The capacitive test point, that's fine, it's live. All right, so that suffices, that satisfies. And then also, we're at a different job site now. All right, we're at the capacitive test point address here in Blythewood, South Carolina. And that capacitive test point address, we gotta go live because what are we doing? We're verifying, Abby's verifying that I have personal accountability at this new job site to her. And I'm verifying that she has personal accountability to me at this job site, okay? So it's gonna take a little longer to do these things, these extra safety, this culture of safety. It's gonna take a little more time. Fairfield Electric Cooperative, you know, they could use another lineman. They're down a lineman maybe, and they just can't get everything done that they need to get done. And I'm going to tell you guys right now, and you guys need to know this is a fact. Every single week of your life, you got tasks to do. You got things to do, honey-do lists to accomplish with your partner, okay? You got all these jobs at work to do. And I guarantee you, you cannot get them done, ever. That's how this life is designed. This whole life we call, right here, body, each other. You can't get them done. You're always behind, all right? But you gotta be safe so you're not caught out in the field being the behind, all right? That's how it works. All All right, so we verified. We're mutually accountable. We're personally accountable. She got a good night's sleep last night. We signed the tailboard that said the same thing. I got a good night's sleep last night. I signed the same tailboard. We're going to add that to our sheet. All right? We're not going to ignore that truth and that fact. And it's the most important fact that there is possible. And so I'm going to go ahead to this other side of the cabinet, or that other overhead conductor, and we're going to verify if we're in phase or out of phase. What you got, Abby?
6.
6 volts. All right. So we're really close to 0. We know that these elbows, because they're a little different, they have a little bit of difference of semicon material, fingerprint, you might say. They're not exactly the same. So they're going to have a little bit of difference of resistance. Therefore, you're not going to get 0 necessarily, but we're real close, so we know we're in phase. Okay, Miss Abby, what you got?
199.
199. We're obviously out of phase. What you got, Abby?
189.
189. All right. You all see that? Phasing capacitive test points. This tool does it because it's accurate, and it sure is a lot safer than going to that hot bushing, isn't it? A lot safer, not messing with that primary potential, but maybe 10% of that primary potential. It sounds a lot better to me. Okay? Now, one thing you don't want to ever do, remember we talked about proper accessories. See that straight probe on the end of that cone tip? All right? We get this call once in a while. Folks have a probe tip on their tool, and they'll go to that bushing, that hot bushing, and put the probe tip inside where that interface is supposed to go from the elbow into that hole. And they call us and they'd say, oh, we had an arc flash. It's like, what the heck, man? That is improper work method right there, buddy. So use a bushing adapter. Some folks didn't realize we had bushing adapters. All right? We do. So use them. They're part of your kit if you're working underground. All right? All right, Abby. So let's go ahead, Abby. Let's take off our straight probes and let's put on our bushing adapters. All right? So Abby and I are going to walk away from our work area. We're going to make a tool adjustment. We're going to make a change. And Abby and I are really good at safety. And Abby knows that when we make an accessory adjustment, we make a tool change, that what we're going to do is we're going to walk away. Go ahead, take that. We're going to walk away from our work area so we don't have a slip, trip, fall, an incident. So we're going to move that bucket just a little bit. Disengage. We're going to disengage. Temporarily disengage. But by doing so, we are engaging in safety. How's that? Huh? We're disengaging from work, but we're still working because safety is part of our job. Okay? Y'all get that? Okay, cool. All right. So what we're going to do is we're going to phase, let's see. I'm going to go to ground. Go ahead, Abby, and go ahead into that hot bushing, that white phase hot bushing. Watch your cord. Keep that away. So this is great training. This is fun. All right, here we go. Go ahead and shove it in. There you go. Okay, what you got?
1.
Okay, so she's got a 1. So the tool is telling her, the tool is talking to her, and she listens. And she knows that that tool is saying that I'm in overload because you've got me on the secondary position. So Abby is going to simply pull out the tool, look at that switch plate. Go ahead. You can get pretty forceful with it. And she's going to go to 25 kV. Go ahead. Okay, guys. Everybody's hanging in there. Okay. And then we're going to try it again before we phase. So there you go. What you got?
13.5.
13.5 on a 13.8. Almost true RMS voltage. That's pretty cool. Pretty accurate. It also shows you how accurate that wireless was now. Compared, it was reading a little high on the other side, where this is reading more accurate voltage on the lower side. All right? So, but we also verify the tool's working properly on a live known voltage source. We also know that Abbi has identified that I am mutually and personally accountable to her, and she is to me. We've identified that fact. So now I'm going to go to the other side of the cabinet, all right, and we're going to simply phase. What you got?
0.2.
0.2. All right. So we got a little bleed in that cord. This cord, because it's shielded, you can use it with it laying on the ground. If we were on wet grass, it would probably be reading a 0.05 or 0.6. Okay, it'd be a little higher. All right, because it'd be more bleed to ground through the wet grass. So, but we know the cord is safe, but we're staying away from it. All right. Now, when we're done high potting, when we're done phasing, every single time, what we're going to do is we're going to always go with the secondary probe to ground first. Always. You don't have to do it in this sequence, but we're going to do it in this sequence. And the reason why is because we understand how these tools work, and we're going to be extra safe. All right? So we're always going to go to the secondary probe to ground first. And the reason why is because Abbi wants to verify the tool is speaking to her, and when she takes the meter probe off, that bushing, she wants the tool to tell her her device is de-energized. All right? So it's more information. Abbi likes a lot of information. All right? So I'm going to go to ground first. Okay, Abbi, just go ahead and zoom in on this one. Okay, hold on. All right, it takes about 2 seconds to bleed off. Okay, go ahead. Go ahead and pull off. Okay, you guys see that? Took about 2 seconds. The reason why it wasn't instant is because of the resistors in both the secondary probe to ground and the meter probe, the resistors. So it takes a couple of seconds, and you guys know that. So remember, when you high pot and you want to de-energize that cable that you high potted, go ahead, however much time it took to high pot with, watch that tool bleed that high potted cable off, maybe through the feed through to ground. You're going to watch your tool tell you that it's de-energized. It takes about the same amount of time to de-energize, depending on the voltage, depending on the length of that source. You're going to add a few extra seconds just to be extra sure. All right? Going to add a little bit more time in your mind. All right? Good, Abbi? That's excellent. Excellent. Okay. Let's go ahead and we can put these up. If you want to just lean, you could lean it against the cone on the other side. Okay. For now. Okay, good. All right, awesome. Can you go ahead, Abbi, and de-energize us? Go ahead, flip the switch. So we're going to go de-energize now, and we're going to finish up, talk about some things. What we want to talk about as well is your TPGs, your temporary protective grounds. I do this a lot around the country, talking about temporary protective grounds. It's fascinating. So something so simple as temporary protective grounds. These are to be considered another best friend. Not your gloves. These are good friends. I was doing training in Florida a few years ago, and all day long the linemen, they leave their service center, and there's a big sign that says your TPGs are your best friend and your gloves are your best friend. At the end of the training, I looked at the operations manager. I told him he needed to tear that sign down and change it. Your air dielectric is your best friend, and your TPGs are your best friend. Okay? All right, so here we go. We want to talk about your best friend. OSHA 1910. OSHA 1910.269. If you go to lowercase n, it talks about your TPGs. Lowercase n. It's important to train your linemen what it says. And there's a lot of employer accountability in 1910.269 lowercase n regarding TPGs. A lot of employer accountability. This is one reason I believe that the linemen that are working for that particular employer are not trained to understand what lowercase n says. Think about it. Think about what I just said. okay? I believe because there's a lot of accountability on the employer side regarding TPGs that lowercase n in 1910.269 is not trained properly. How do I know that the linemen are not trained properly? Because of what I'm about to say. All right? And I've been around coast to coast, thousands of linemen. And there were particular employers, contractors, that's a big one, municipalities, IOUs, true story, and cooperatives that were not training their linemen, lowercase n, temporary protective grounds, what's in the OSHA regs. Think about it. After an incident takes place, then there's some training maybe. Just think about it. After the incident takes place, then there's some recognized need for training. So now let's talk about lowercase n. Okay? You should read them. But in there, number 4 talks about how you're going to use the IEEE 1048 and how you're going to use the F855 as guidelines. Oh, huh. Then there's a couple more things that we should probably look at. That's true. True story. Remember, Brady Hansen says these are the lineman's scriptures right here, OSHA. And it's a true story. He's right. Okay? So what we're going to do is we're going to talk about your TPGs. The reason why is because it's not being talked about enough or at all in some instances. I've seen it all. All right, so you want to visually inspect your TPGs. Visually inspection. You're going to look for a lack, an absence of any pinched cable, smashed cable. You do not want to see any blackened copper, patinaed copper. You don't want to see any broken strands. If you can see through your jacket, you don't want to see any broken strands. You don't want to see any cracks on your clamps. All right? And you don't want to see any obvious loose connections that even look loose. Make sure everything looks good. And a big thing that I found in the industry is you're going to look for a lack on your components of oxidization, residue. Make sure they're clean. I have seen it. Everything we just said, I have seen it all. Okay, visual inspection. You also want to do a mechanical inspection. So you're going to grab a hold of that assembly and you're going to verify that that cable is nice and tight in the crimps on your ferrule. You're going to try not to be able to wiggle it, pull it out, or anything. There's no movement. Solid, like a rock. That's a song. Okay? I think Bob Seger sings that. I don't know. It's been a while. All right? You're going to make sure that your ferrule is tight inside that clamp as well. Okay? No jiggling, no wiggling. Okay? So verify. If it looks good, mechanically, it tests good, typically they're gonna take care of you, your best friend, on the job site. If they get hit by a potential fault current, they'll protect you. You also want to verify that there is a date stamp on your assembly when it was last electrically tested. Believe it or not, there are still folks that, to my face, say that they do not electrically test their TPGs. Fact. Unbelievable. That's crazy. But the guidelines say too. They do not say how often. Makes zero sense to me. Doesn't say how often. Okay. Some folks do it 18 months. Few 24 months. I think that's way too long. Most folks that electrically test their TPGs test every year. So verify that you're in compliance. Verify. Make sure that your date stamp is in compliance with that once a year or whatever testing program. You could do storm restoration, you get called out, and you might get skipped. So verify that you did not get skipped. Comprende? Okay? We speak several languages here in South Carolina. Spanish, a little French. All right? It's important to connect. Okay. So now what we're going to do is we're going to electrically test. But before we electrically test, we want to show you all something. We want to show you guys that we're going to always electrically test with these in parallel configuration to mimic real life use when you're out in the field. Because in real life use, you're going to take your TPGs when you use them, and you're going to go from point A to point B when you establish your EPZ. All right? You're going to go from point A to point B, and you're going to go in a straight line. You're going to have some droopage between conductors. That's fine. But you're not going to have any of your TPGs in a coiled configuration as such. Y'all see that? I was doing training just, when was it? Last year in North Carolina, in fact. I won't say who. Last year in North Carolina. And these guys were using these long assemblies. They work in transmission. They were using these long assemblies on that high kV line. But what happened is they'll come down to the lower kV. When they come down to the lower kV, what happens is they're using the same assembly. Instead of having another set, shorter set, they use the same assembly. And the guy that came to me and spoke to me alone, and this happens a lot, and it's just, I can't believe how often this happens. He spoke to me alone, and he says, hey, when I'm on that 69, I like to go ahead and get some electrical tape, and I'm going to tape it up and coil it. And you're telling me not to do that. I'm saying, I'm not telling you not to do it at all. That mechanical field that I showed you in the class that you just learned about, it's speaking to you not to do that. He's like, okay, so why don't you have your boss, why don't you have your tools man, thanks Skylar, why don't you have them buy you a shorter set? Bing. Culture of safety. Electric culture of safety. Bing. Okay? Takes a little more money, maybe, to talk about, to share, to be a part of, to participate, to indulge in the electric culture of safety. Maybe just a little bit more money. But guess what? Your linemen, instead of being one guy short, not being able to get all your jobs done in that week, your linemen aren't going to get an arm blown off. Then you're down 2 guys. Your lineman ain't going to get smoked. All right? He's going to go home. She's going to go home to her family. He's going to go home to his family every single day. So at least you got them. And they're going to live a long, beautiful, happy life in the most beautiful career and enjoyable work that there is possible. All right? Because we're electric beings. Think about it. That's why we like doing this, because we're electrical beings. So we like to work with electricity because that's what we are. Okay? Same thing. All right, so you're not going to do the coil. All right, Abby, you ready? You don't have to have gloves on for this. Here you go. All right, so Abby, we're going to crank this up, this grounds tester here. This is Walter's first tool he came up with 35 years ago. We've been in business for over 35 years. This was the first tool. All right, and we're going to put true ASTM, page 2, table 1 of that F855. This tool was built. Walter actually built the tool around those guidelines. All right, and we're going to crank this up to about, 300 amps. You guys see that amp meter right there? See it, Simon? Okay, about 300 amps. And that 300 amps is flowing through this cable, and I feel it. You want to feel that? Abby, it's safe. You feel that? Isn't that cool? Yeah. It's exciting. Sometimes when I'm gone from I'm away from my wife for a week or two, traveling around the country doing the lineman safety and tool training, I mean, just doing this part right here makes the whole training worthwhile. Right here, okay? You guys think I'm doing it for your benefit? All right, here we go. Abby, go ahead and run that bottle with the magnet toward the bottom, right through that center of that hole. All right, y'all see that? That's truth. This ain't a theory. Pretty awesome, isn't it? Huh? This is exciting stuff, what we do. All right, guys. Okay, Abby, now we're going to take the same current, and we're going to test, when we test our grounds, you're going to test your grounds in a parallel configuration, maybe a 2x12 with 2x4s on each side, all right? Or twisted. That's going to mimic that point A to point B parallel, and it mitigates most, not all, but most of that magnetic field, all right? Okay, Abby, come to that center. Little bit of buzz, little fuzz, but a lot less. Y'all see that? A lot less, okay? All right, very good. So that's proof. It's not a theory, it's proof. We're proving to you why you're gonna work safe, all right? So what I'm going to do is crank this down. It requires to properly test. This is a number 2. We suggest you all use a number 1 or 2 aught because it's less flimsy and the strands will not tend to break under that jacket as easily if it's more stiffer. All right, and we're going to come down. It requires 165 amps. We're going to bring this variac down to 165. It's a beautiful day in South Carolina, so it's not too hot. We're in the shade. We're in a kind of a controlled environment. You don't want to do this in the sun. All right, so it feels nice out here. Actually, it does. All right, and we've got 165 amps. We look at the voltage drop, 0.22. So the chart, if it's a 0.24 or less, it passes. So this passes. It's good. All right. These contact points should be cleaner, but they're not. We do have a little heat here. We've got 165 amps flowing through this, but very little voltage, so there's no shock potential. So the tool's very safe, but I feel a little heat here because of grime. All right. Right there. And there's some resistance building up that heat. Okay. We're good so far? So that's your grounds tester. Any questions? Any questions? We're good, Jeremy? Okay. All right. So what we're going to do is we're going to talk about proper body position. We're going to talk about improper body position. We good, Jeremy? We're going to talk about proper tool position, improper tool position. This is important. Most linemen don't receive this training. You know, we do this training. When we do this training, a lot of the op managers, most of the safety guys, pretty much everybody, linemen, they say that this training should be mandatory. All right? I fully agree with it because guys are getting hurt because they didn't get it. So it should be mandatory. It makes sense. So why are we starting ECOS? We started ECOS so you guys can get some of these trainings. Some of the best speakers in the world, literally, have joined up ECOS, willingly and freely giving back to our industry, to our line crews, at no cost. All right, 0. That's cool. So you need to share this with everybody. Share ECOS with everybody. Electric culture of safety, we're kicking butt. After 6 months, we already have 4,000 members in 6 months. And everybody, look at our latest logo, man. Bulwark's coming on board. They endorsed it. We're getting endorsements. Wait till next year. This thing's going to blow up. But it's going to blow up safety. So nothing else is going to blow up. All right. So we got ourselves a corner pole right here. All right. That's a corner pole. And I get a call from a guy in Illinois, and he's a lead lineman, about 20-year lead lineman. He's a shepherd of the flock. He's the lead lineman that is an example for everybody, all the apprentices, all the other linemen, through his actions, through his work methods. Okay? He calls me up and he says, hey, Brent, your tool's no good. I got an analog and I'm in the bucket and I'm getting 13,000 volts. And so describe to me. Well, I'm at a corner pole. I'm getting 13,000 volts on your analog tool on 7200. Your tool sucks. Not accurate at all. So what happens is I tell the guy, I said, look, I'm not going to argue. I'm going to get a plane ticket, fly out, and give you guys some much needed lineman safety and tool training because you need it. What do you mean? I need to send the tool in for repair. Nope, hang on to the tool because in my mind, I already know what's going on. All right. So what he did before the training, he's at a corner pole. He's got these phases behind him. And when you all are working hot, you need to always work as if that potential is your enemy. You don't want to work, if at all possible, with that potential at your back, your enemy at your back. All right? When you go home, you flip on the light switch, give your partner, your woman, your man, give him a hug. All right? Her a hug. Turn on the lights. Grab a nice cold brew. That's fine. All right? That's fine. That's where it's a blessing, that power. All right? But not when you're working hot. It's not a blessing at all when you're working hot. So what you're going to do is he had his back to the enemy. That's improper body position. First, he was short sticking in the bucket truck. Improper body position. Number 2, mixing 2 together, improper things together. There's not good work methods here in any of this. So we did the training. And then he got in the bucket truck. He took the broke tool And here's him, same exact location, same exact spot. He's in the bucket truck. He gets back on his stick, his hot stick. Same location though, but the enemy's in front of him. And he's getting 7,400 volts on a wireless analog. Pretty accurate, pretty safe. Proper body position, proper tool position. And he's getting 7,400 volts. The tool miraculously was healed of all of its hurts and diseases. But it was actually, the fact is, he was a wireless, living, breathing phasing tool, out of phase. That lead lineman was out of phase, right up here, okay? He never had this training. So make sure you have proper body position. I had a guy in Louisiana, same exact thing, all right? Same exact thing, corner pole, he had a horn and light. He had a horn and light. Horn and light was going off. He said, man, your tool's broke, sucks. I said, did you test the battery? Yep. Did you test the tool on a live known voltage source? No, but I will now, and he did. And the tool worked perfect. And I told him, I said, there's nothing wrong with your tool. He said, yeah, there is. I got the switch open and I'm getting a false positive on the conductor. He showed me the video. True enough. Switch was open. True enough. That tool was giving him a hot indication on that long source. I'll tell you guys what. He had his back to that corner pole, short sticking, and that tool was going off and giving him a false positive. That's what he told me. But I told him that that conductor is absolutely energized. What do you mean? Check this out. Because he was coupling with capacitance across his back, cross his gloves. Cross his gloves. He had a PP on, cross his gloves. That's what happened. You guys saw it. It's a true story. You see the voltage right on the rubber. Right on the rubber, running fast as it can go to the ground playing me. And that's what happens. And that's what happened to him. And it was flowing across his gloves, through the tools, this direction, to that conductor, giving him a true positive. It was a real positive, all right? That conductor is energized because, not with the full potential, but with induction. Huh? And the tool told him that. So the tools talk to you. If you're using the tools improperly, allow that tool to speak to you. Maybe you back off a little bit. Whoa, let me look at this job site. Let me look at my body position. What am I doing here? I tested the tool on a live known voltage source, tested the battery. I know the tool works. All right, tested it with test the tester. The tool works. And the tools tell me, I got the switch, the tools tell me, what am I doing wrong? Tool didn't do nothing wrong. What am I doing wrong? Think about these things. Reposition. Proper body position. Change the scenario. Change your thinking. Okay? Don't always say, we get this call, oh, we had an arc flash. Your tool sucks. We're going to start buying another manufacturer. Okay. You guys, that's fine. Go ahead. We have plenty of sales. We can barely keep up. That's actually a true story. So go ahead. But before you do, you all need, because of your picture you showed us, I will get a plane ticket. I will fly out and give you some lineman safety and tool training because you guys need it badly. And after that, if you want to buy somebody else's tool, that's fine. You'll be safe there too. All right? So we do. And what happened is these folks, I don't want to pick on this same state every time, so I won't say the state. But anyways, these folks, they had a PD 25 right here. True story. They had a PD 25. What happened is they went to that substation and they looked at that hot bus right here. They didn't have a bushing adapter on. It was a straight probe. But they had a hot bus. They made contact with a hot bus. Check this out. Corded, okay, phase to ground. Going to ground. This meter head in this particular utility, the meter head was next to another hot phase. So instead of inspecting their work area prior to using the tool and knowing how these tools function, they should have put on a 0 ohm extension prior to use. But they didn't, because they needed the lineman safety and tool training, so they didn't know. So when they made contact, and that hot bus was right here next to the meter head, they had a cross phase arc flash, right? And that's what happened. And that potential shot down that cord to the secondary probe, blew up there, blew up at the housing. And there's a big O on that gray painted equipment in the substation. There was a big old moon crater. Like watching the moon, big old moon crater of that damage that happened. The linemen dropped their tools and went screaming, running like girls. True, Abigail. True. All right? They went running, screaming like girls. I can say that because they actually told me they did. So they were being very open about it. It's a freaky thing, having an arc flash. It'll mess with your mind. But they just didn't get the proper training. They didn't know. But they did get proper training in this aspect. You might ask, what aspect? So I'll tell you. All right? When they were working hot, they were back 36 inches back from their meter head. And they were 36 inches back from that cord right there. All right? They did train that as a proper and safe work method. And because of that, they actually were safe. And because they were trained to stay 36 inches back from the cord, 36 inches back from the meter head, they were able to tell me their story. Think about it. What if one of those guys had that cord next to his thigh and that full potential went down that cord to ground? Step potential, huh? May have lost his life, may have lost a leg. Don't know. Good thing we don't know, because they're fine, they're safe. They just got some screaming voice lessons, that's all, that day. All right? All right. Any questions thus far, guys? Anybody have any questions? So, here's the deal. We're going to talk a little bit about ECOS. We're going to wrap this up. Electric culture of safety, all right? Because what's happening is everybody's being trained safety. This individual contractor, this individual electric cooperative, all right? This individual, big, giant, investor-owned utility. They're being trained safety all the time. But what's happened, this is what's happening is we're doing it all the time. We're talking about it all the time. But what happened is, what's going on is that we got these walls. We got these walls of separation. We're all individuals, all right? And I tell you what, that right there is not a culture at all. That right there is self. And you're trying to protect yourself. And here's what happens when you don't share and you're not a part of the community and you're not sharing your care for one another, your neighbor, all right? It's all about you. When you're not sharing that, what happens is people get hurt. Their hearts break. They get the feelings hurt. Okay, true story. Think about it. They get mad at each other, angry. But what's happening in the electric power industry, what's happening is folks are getting hurt. Losing hands, fingers, arms. They're not going back to their kids that night after they got to that storm. All right, they're not being able to see their grandma and grandpa no more. Grandma and grandpa, their child their grandson or granddaughter ends up leaving them, and they're still alive. That ain't right. That's all backwards. And see, when you're not sharing safety with each other, that's backwards thinking, folks. We got to break down these walls that divide us. We got to break down these walls between us. You know, you see all these fights. Oh, you're union and I'm non-union. Oh, you're a rat. This is the most disgusting words I have heard from people. Stuff like this is bizarre. Hey, I know why some guys work non-union. I know why guys work union. All right? It's okay. Let's just get along. All right? Someone said that. Can't we just get along? All right? So what we're going to do is, how we're going to get along is we're going to come together and share safety. And that's what ECOS is all about right here. Electric culture of safety. It's what it's about. So what we're going to do is, we've got speakers. Check this out. We got, man, I got to settle down here just for thinking about it. So we got Billy Martin coming in again. We got Danny Rains coming in again. We've got keep your heart and your mind on Jimmy Vaughn. You know, just keep them in your heart and mind. We've got Dwight Miller coming in. We've got Caleb Thompson coming in again. Brady Hansen coming in again. We got David McPeak coming in. We've got, man, I don't know, everybody's coming in. All booked up for a year now. So many folks. Eric over there at PG&E, he's coming in. We got a lot of good folks coming in. All right, good, well-meaning people that want to share, and they do. Emily Wilkins, Austin Energy, she agreed yesterday that she wants to do this and be part of it. Man, she's awesome. All right, Abby's going to get hooked up with her. Buds, mentorship, right? All right, so what we want to do is, you guys are welcome to take this. You guys are welcome to share this or not. I don't care. All right, but we're going to do this. How's that? So we're gonna talk about these high voltage athletes. All right, that's what we do. We're high voltage athletes. We got to have understanding. Understanding is what we're talking about today. Understanding equals knowledge. Okay, so we give you understanding. You got the knowledge now, and what happens is people don't perish. Right? It says that my people perish for a lack of, right here, knowledge. Okay? So what's going to happen is we're going to share with our high voltage athletes all this information. All right? That's what we're doing. We're going to share it. And the perishing stops. The deaths have flatlined. The deaths are still here because we're human. The deaths are still here because we're separated from each other in our heads, and we're separated from each other in our hearts. Because it's all about us. And that's bullcrap. If you're on the line crew, it's not all about you, and that mentality has got to completely stop. There's no more yelling at apprentices. That is ridiculous, because doing that causes shame, doing that causes pain, doing that causes injuries and incidences. We're a team. Boom, baby. All right? So we're going to communicate right here. I'm not going to go into detail. Go to the IP conference. We'll talk about this more. I'll be speaking there, and at the International Linemen's Rodeo as well coming up, okay? We're going to communicate. Communication, connecting. We're going to speak up. We're going to connect our minds, our hearts together. We're going to talk about things right here. We're going to speak up. You see an issue? You're going to speak up, and the rest of you guys are going to allow it to happen and embrace this. You're going to embrace the speaking up. We're going to have commitment. You're committed to that day before the day even began. You're going to have mutual accountability, right? We got compliance. We're going to keep in compliance. We're going to be obedient to our safety. We're going to be obedient to our work methods. We're going to be in compliance to watching out for each other. Huh? That's part of compliance. You got work methods and everything is written down, but there's a heart thing. There's a mind, a consciousness that we got to connect here. We got compliance. We got discipline. All right? You guys are high voltage athletes. Do you not think that anybody that's on a winning football team is going to have discipline on their plays and how they work things? Yeah, we're going to have discipline on the line crew. Okay? Accountability. We talked about that. Don't need to talk about it anymore. That's going to be on our job briefing. All right, right there. Accountability, mutual and personal. Okay? Practice. You know, right here. Practice, practice, practice. Every day we're practicing. We're working hot. We're practicing safety. We're practicing our work methods. We've got our mind focused on what's happening because we are a high voltage athlete on a winning team. All right? Coaching. What do you think I'm doing here today? What do you think ECOS is all about? These folks that are speaking, Jim Duncan in September 14th, what do you think he's doing? He's being a coach. All right? And the coach, what here? Me? Him? Everybody. Danny Raines? Everybody. We got Manny with El Paso Electric Company. He's going to be coming in June. What do you think he's coming here for? He's coming here to coach. So a winning team, if you guys are high voltage athletes, we got to have coaches. A safety guy is not just the safety guy, and no one else is the safety guy. A good coach, right here, a good coach is going to make everybody that's on this team, high voltage athletes, they're going to be coaching each other too. They learn, they get the gift of coaching, and they share it right here with each other all day long. Hey, you guys email me right here, safetytraining@biermeters.com. I'll send this to you. You could use it, keep it, I don't care. All right? Whatever. Right here. Slow is smooth. That's what I learned it when I went to Northline Utilities Safety Conference. Did some speaking there a couple weeks ago in New York. That was pretty up there. Hot as a heck, though. It felt like South Carolina. Slow is smooth. Smooth is fast. That's what the coaches taught me. So I'm coaching you the same. Slow is smooth, smooth is fast. All right? Think about it. If you're going to stop the job for that day and you're going to have to do some investigation, everybody goes back. We're going to realign our minds and our hearts, our equipment, our protection, our thinking. We got to realign it and come back the next day. You think that's smooth? You think that's fast? Getting the job done? That don't fly. So we're going to take our time. Slow is smooth, smooth is fast, and you're going to have all your linemen, all your line workers that's on your crew, they're going to go home every day. And they're going to come back because they love you, because you care about them. Huh? Got to share the love, man. Safety is about love. Okay, think about it. All right, right here. Reap what you sow. If you guys are sowing all these attributes, all these characteristics of ECOS, right here. This is characteristics of ECOS. You're sharing that. You're living it, breathing it, sharing it, coaching it, complying to it, speaking up about it, connected, communicate, all these things. You're going to reap what you sow, and right here, you're going to reap this right here, equals electric culture of safety. How about them? How about them apples, huh? We're going to go from being safety. We got so much safety going on. We got our bellies full of safety, all right? And what happens is we're pooping out safety, all right? And it does no good. All that safety does no good for you guys, your line crews, your line team. Zero. If you guys do not hold an electric culture of safety, all that safety, all those safety meetings are almost, not quite, almost a waste of your time. You get it? Get it? Got to be together. Electric culture of safety. All right? Abigail, close us up. Say something.
I don't really know what to say to wrap that up, but safety to me is the most important thing, because at the end of the day, I get to go home to all my loved ones and get to enjoy time with them. We only get one life to live, so let's live it to its fullest.